Physiologists and biomechanics or biomechanists have not long known that there's a big difference between the bird lung and the mammal lung, and our work is kind of figuring out what the reptile lungs are about, and they're kind of phylogenetically in between those two. So we're trying to sort out the evolution of lung structure and function in vertebrates on a broad axis, comparing bird lungs, which are pretty unidirectional, to mammal lungs, which are pretty tidal, and we're doing that by looking at reptile lung structure and function. We're addressing not only what are the biological importance of unidirectional versus tidal lungs, but maybe trying to figure out what animals have what, and what evolutionary scenarios could have led to one lung or the other. I think our work is important just for kind of figuring out where we came from and figuring out how the natural world works. People want to know where animals came from and where we came from. And the more we know about the different evolutionary stories that led to one lineage or another, tells us a little bit more about where we came from. Because we're studying these really complex but also simple aerodynamic structures that don't have any flaps or valves, figuring out how the fluid dynamics works in these lungs could really help engineers potentially build more efficient devices or heating and cooling or aerodynamic valves. Before I started working on Blue Waters, I had been a heavy user of the University of Utah's high-performance computing cluster, which is a great resource, similar to Blue Waters, just smaller. Blue Waters is great for our research because a lot of the software we needed to use was already installed and well supported on the system. We're looking at using this open source fluid dynamics library that a lot of other people had used, so there's a great support from Blue Waters architecture and staff that way. And also the computer's so big that we could put these large jobs on there and wait a while and they would work through the queue and we wouldn't have to babysit them as much as we normally would. I've learned a lot about computing resources both on campuses and nationwide. I feel like if necessary, I'll be able to plug back into whatever the next computing system is after Blue Water, or exceed resources, or definitely use resources on campus. I got really hands-on support from several staff members in terms of building the code, from compiling it and getting it to work, and that was great and saved me at least 10 hours of trying myself. The things that are outside of my expertise that I need to have done, I don't have to learn. I could just farm out to people that were trained in those things. So because of Blue Waters, I was able to add another aspect to my PhD research that looked at not only big picture differences in lung structure and function, but also species comparisons within a group that is going to, I think, change the field a lot.